So, my favorite part of the AI revolution is the leveling of the playing field so that everyone can have things like blogs, which are the new version of newspapers, podcasts, which is the equivalent of a radio station, and even at their own TV stations, which is what we're doing today with streaming. But that also has consequences. AI is going to do a lot of good things, but also bad things in the future. And I want to talk to an expert on what powers the guts of AI, which is data engineering. So today we're talking to Vinu Ganesh, an authority in software and data engineering. He started his journey at Palantir Technologies, and he recently released a course for LinkedIn called Hands-On Introduction to Data Engineering. So Vinu, your education is in computer science, finance, and philosophy, which is awesome. But you're really focused on building pipelines and engineering teams at investment groups, a geospatial intelligence startup, and building engineering teams. So tell me a little bit about your transformation from all these different fields. It sounds like a fascinating journey.
Absolutely. Yeah. Thank you for having me, Ray. My career has really been focused on taking technology and applying it to critical mission problems across virtually every domain that I can. For me, I've always seen technology as a means to either bringing change or problem solving for humans in like interdisciplinary ways, uh, especially when those problems involve operationalizing data, whether it's healthcare data, financial data, or geospatial. My goal in my career and my goal in building technology is really to get as close to customers as I possibly can, specifically to understand their problems and actually build something that is meaningful for them, really in any way. I've done this in a few ways. I've gotten a chance to work directly with the military in places like Afghanistan. I've gotten a chance to even provide technology for EMTs moving around New York City. It's really just been focusing on how can I use my technology skills to improve people's lives. I also have a kind of a thesis about data as a whole. I think data is the ultimate disinfectant. It democratizes people's ability to gain meaningful insights, especially people who may not be able to analyze that data without specialized tooling or specialized knowledge. So bringing data to people and allowing them to operationalize that has been my driver.
Yeah, that's pretty amazing. And I totally agree. It's been so life changing just in recent times to be able to see the changes that AI is just so quickly bringing to everyone. And I love that because that's where it's really exciting. You no longer have to be, from a special school or from a special, section of the population to have an opportunity today. You just have to go do the thing. And, now the AIs are just giving you these amazing tools to implement all those things. But I'm really curious, and I can't help myself to ask about your philosophy and your finance. I know you have like a supremely solid computer engineering background, like implementing all these things. But talk a little bit about how those things have kind of informed like your understanding of AI and maybe part of your career.
Absolutely. I think the financial side of I studied philosophy actually at King's College in London. And for me,
Hmm.
that was just a way of actually understanding and conceptualizing my world. So looking at not only like famous philosophers, but also really like crafting an ideology for the kind of person I want to be or the kind of or the kind of problems that I want to solve. That was a pretty fundamental part of the philosophy education. I think finance is very interesting because it actually has a lot of parallels to computer science. They're both rooted in systematic problem solving. They're both rooted in like data, numbers, understanding and breaking down complex problems. So for me, looking at a technology or a space rather like finance and comparing it to computer science, they're similar. They're more solving the same problem with two different lenses. So how
Hmm.
can I optimize something, or how can I deploy capital? How can I deploy compute? Those very similar problems.
Yeah, I'm really interested in how you actually transitioned from every one of those. Like, did you start with philosophy and then moved into finance and then computer engineering? Like, how, and then, how did that kind of turn into like your first jobs and opportunities?
Absolutely. So I started with computer science. Always saw computer science as really an outlet to being able to solve problems without having to rely too much on other people or other pieces of infrastructures. If I, as an engineer, many people need labs, nano fabrication facilities, wet labs, dry labs. As a computer scientist, you just mostly need your computer. So the
Hmm.
ability to immediately make an impact and quickly has been something that really drew me to computer science. Now, finance, I added on around, I want to say my sophomore or junior year, just given that I met a lot of cross finance and cross computer science folks and realized that an application of what we were building will always be finance. Computer scientists have permeated the industry, spent some time at Citadel myself, and I think it's really exciting when you're able to bridge two versatile and independent fields like computer science and bring that knowledge set to finance. So it really just came about as me saying, what would be interesting to learn in the time that I'm in school? And then ultimately, when the philosophy thing came up, it was, I felt like I had a pretty good technical education and a good understanding of, like how to do things with data, how to do things with numbers. But that abstract idea of what does applying this actually look like? And what does it mean for society? What does it mean for myself and the kind of person I want to be? Crystallizing those thoughts. Studying philosophy helped me too. And I do want to say I am not a philosopher. I don't have some novel like categorical imperative kind of thing. But I think understanding how people actually frame problems and how they can articulate theses about the world help me also frame what my thesis should be and what I want to do.
That's such a good transition, and for some reason, it wasn't sort of the answer that I expected. I don't know what I thought the order would have been, but I do find that with everyone I'm interviewing, I see kind of a similar trend. That it's not just people that maybe grew up in finance or has always been financing in finance, but or people that just study hard computer science. It's always people who are high performers who are interested by other fields. We've had people with like a neuroscience background, definitely computer science, of course, engineering, a lot of business and finance. And I feel like that combination or the ability to be able to connect different things is what makes people like special and be able to do some of these kind of larger, take on some of these larger products because they have a kind of fuller understanding of everything. So last week I was talking to Priya about when companies should avoid implementing AI, for example. Some don't really have the infrastructure to support it. So I'm curious what you think in your assessment. Where do you think most companies are today in terms of their readiness to implement some of these AIs and tools?
Yeah, absolutely. I think what's really interesting about the evaluation of whether companies are ready to adopt AI is these problems are the exact same as is a company ready to operationalize its own data? Do they have a data strategy? What does the current infrastructure look like to actually get meaningful insights or meaningful value out of both internal and external data sets? It's interesting. A lot of the same kind of like mantras that the data engineering folks, the data quality or observability folks have been saying about companies over the years still rings true with this. I don't want to call it a revolution, but with the advancements in AI. Are companies actually data first? Are they data driven? And do they have the infrastructure to back decisions that they make, both internally and even externally, with actual core meaningful segments of data?
Hmm.
I think from an infrastructure perspective, there's vendors. I think obviously I'm biased, but Palantir has done a great job of
Mhm.
actually helping people operationalize their data. Companies like Databricks have done a phenomenal job as well. And I think what that really means for an AI-driven enterprise is people now have an understanding of the value of data. And it almost serves as a blueprint for the firms that have adopted that understanding uh, for how to use AI and how to use data to feed AI to make meaningful decisions. So I really think the AI readiness conversation almost exactly mirrors the data strategy conversations. So is a firm ready to make meaningful use out of their data? Sounds a lot like is a firm ready to make meaningful use out of AI?
I feel like the speed of AI is causing some companies to maybe jump into something like AI before they're ready. There's like, I was talking to you on the pre-show on how you have been around AI for a long time, like longer than, when it was popular. recently, so that the companies that you've built have always had that as their DNA. In the same way that a company like LinkedIn, they've always done machine learning, AI, all these things. It's just that now that they're really popular, everybody's looking for sort of a quick in. And I think that understanding that if you haven't been ready for AI, your AI's implementation is going to show that. So having that sort of varied outlook of not just trying to shoehorn something in that's not going to work. I think that's super key. And that's how I think you're going to really find out the companies that have been doing it for a long time. The products that they're going to develop are going to be so much better and more impactful, I think.
Yeah, and I think what's especially interesting is, I've never actually built a company with a focus of being like 100% focused on AI. For me, it's always been a data focus. Like, how can I meaningfully either help this company or help our customers operationalize data, whether that's through pipelines in Spark or like even Snowflake, or like how can I do something meaningful with data on my own? Like, are there meaningful insights that I can get from data sets that I've bought? And I think what's interesting is, I've never seen, uh, I never built something rather with the direct goal of trying to train a model and build some deployed thing. For me, it's really like, how can I meaningfully use data? And if AI or specifically these machine learning models end up on that critical path, then using them is something that I think it's really powerful. I do think one of the things that's interesting is this idea of generative AI is kind of
Mm.
the
Mhm.
it's it's interesting in a lot of ways where now a model is interesting and capable enough, I should say, to generate content that is non-deterministic by nature. I think that actually can lead to a lot of positive and negative outcomes. When I have something that can give me a different answer every time I ask it the same question, non-determinism is actually pretty scary. Whereas in things like SQL or programming languages like Python or regular data set or tabular analysis, I generally get almost 100% of the time get the same answer if I ask the same query to the same data. So there's that gap as well around when this generative stuff comes in and the inherent non-deterministic part of machine learning. How do companies or organizations bridge that gap? And is that a showstopper for a lot of them?
Yeah, I think that I have definitely found that the first question that people have is how do if I type in the same query or the same prompt into something like ChatGPT, does it give you a consistent answer? And the answer is it does, it doesn't. And also that you can't trust it. Like, and that's the other thing. Like, we haven't sort of gotten to the point where you can really trust what it says. And we've never had products where you really had to ask yourself, okay, I'm going to use it, but I can be 100% sure that the information that it's going to give me, that I'm not going to be able to trust it. That's never happened. The generative AI, I think that people have to understand what it's for. It's solely, I think, extremely good for creative type of projects like generating, art. It's really good at doing that. Now, if you want to get a very specific piece of art that has a specific element in it, it's going to be really difficult to do that because it's almost like too creative in a way. So that deterministic aspect, I think, it's kind of hitting people now. It was really novel at first, very exciting. It does do a lot of things, but you can't do research with it right now because you can't trust anything that it tells you. But that means though that things like brainstorming, it's fantastic for doing that kind of stuff, for like organizing things and planning. It knows patterns, like that ability of the AIs to understand patterns and then do things based on patterns. Was anything besides sort of that creativity that comes from generative AI sort of something that you saw coming, or is there something that kind of you didn't see happening? Like, I know the video stuff for me, I would never think that it feels like we're getting closer and closer to sort of, predictive like video generation. Is there anything that you've seen that you think is really kind of surprising to even somebody that's been around for quite a while?
I think what's interesting is, this is probably going to be a controversial statement, but the major
Oh, that's great.
advancement, yeah, the major advancement we've seen in the past, I would say, like even 2, maybe 3 years, is just the size of these models getting larger. Like literally the number of parameters in these models getting larger. I think what's interesting is you traditionally had tended to see, let's pick a large language model, for example. Just the number of parameters in this model, or like the number of, even like we just call it features of this model, grew, and it grew substantially. Like some, they've grown into the billions. The the new advancements have really been, how can, when we have a scale of a model this big, are there material improvements in the performance of the model? And I think we
Mm-hmm.
found with something like a chat GPT, the answer is yes, right? Or GPT 3.5, GPT
Mm-hmm.
4, there are material improvements. I think what people now see is the ability to use these larger scale models in really productive ways. And you mentioned some stable diffusion kind of models,
Mm-hmm.
like the ones that are generating images. Video ones are coming. I actually did like a voice change one recently. And so I think the the size of the models expanding is definitely something that was likely to happen. And a lot of the large players, your Microsoft, your Googles, that have the money to spend on that, is they can build these things pretty easy, these foundational
Mm-hmm.
models pretty easily. What I think is going to be really challenging moving forward is the idea of a context for in context learning. If you look at a context, specifically in a large language model, how these models generally work at a high level is they take in a bunch of tokens and then they figure out what the next token is from a probabilistic perspective, and then just keep following that chain down. And what's pretty interesting about this is when companies want to use their own data in these models, there is a context size limit. You just can't include that much information. Some of them are 8K, some of them are 32K. Anthropic just released 100K context length model. That is a really, really sensitive area, because that's exactly all the information that I can include inside a query to one of these models without having to fine tune the model and spend a bunch of money on it. So I
Mm-hmm.
actually think a lot of innovation will come up in this context window field and this context length field. Ironically, it's one of the things I'm building, but that's exactly the area that I think. And you asked me, like, what are the advancements that you foresaw coming? We knew models were going to get bigger. I don't think people understood how much of an optimization problem getting data into your context window is going to be.
Yeah, and I think that the problem that we have now is that the models are so large that only certain companies are able to use the models, to run the models. And I mean, we're hearing about companies not being able to find enough chips, like the physical problem of AI. We just saw, I think, LK99, which is that new sort of material that is supposed to be, able to do things at room temperature that only super cooled materials could do before. And they're saying how that can possibly now lead to new developments, but those are years away. And so we have this like weird world in which only big companies can do this right now. Even though I think, like you said, I think one of the interesting thing is that contextual model, that not everyone can run these models, and so you see only certain companies doing it, but also that nobody can kind of, that idea of context where if you want to do something based on other things rather than just the current chat, that is really difficult for a model to be able to handle. Like, say, if I'm doing this weekly show and I do, I come up with a set of questions and I usually have AI help me with that. If it was able to understand the questions that have been asked before, it would be, perhaps it would have the capability of doing a better job at doing things today. So that aspect of not just being able to handle the current context, but then additional amounts of context. Or say that I was a shop and I wanted to have AI help me generate some, advertisements or something. Like, I can't really just feed it all my data. You can try to fine tune it, but it doesn't kind of it kind of has like a, almost like a short-term memory in a way. Like, it just understands the context that it has while it's running, and then the context that it has from all the training, but it's not really able to sort of group together sort of contexts. And I think that's really interesting. So I'm glad people like you are thinking about those things. And I think, yeah, it's been really surprising to me, the capabilities, especially I think the generative AI, like the art tools. I didn't think that that was going to happen. Like, I didn't think that computers were going to be able to combine techniques from different like artists and be able to come up with like new styles that I hadn't seen before. which is funny because I used to work at a newspaper and I used to watch the artists like draw art and infographics for the newspaper. And I would always see them, if they had to draw like an illustration or a caricature of somebody, they would always pull up like 100 pictures of the person, and then they would draw in their own style, at the caricature based on what they saw. And this is exactly what the computers are doing now. They're able to analyze patterns from a large sample and then come up with some sort of style once they understand how to redo the patterns. But I just didn't see that coming. Like I didn't see the computers, you know, I don't know if it's that being that intelligent or just being that kind of intelligent, right? And that's kind of what we're seeing today.
Yeah, I think what's interesting is the applications of these generative AI models has really been the area of innovation. I kind of jokingly said, when crypto came out, everyone was like, "This is going to change everything," and we don't have any real applications for it, right? But here, these models of the advancements in AI that we've seen, they've come out, and everyone's like, we have a billion different use cases that we can deploy this in. And so I think
Mhm.
the creativity of how you use these models is actually the really interesting thing. And of course, there's challenges that come up with a lot of that stuff, right? One of the ones that you've mentioned is the short-term memory of these models. And we're seeing a lot of technology in the space, like vector databases, which and semantic search, which are effectively hacks around getting only the information the model needs and feeding that into the context. And so I think there's as more and more advancement happens in this space, and as people want to integrate more and more data into these models, the infrastructure and the fundamental data infrastructure, I should say, is going to need to see a lot of changes, a lot of developments as well.
So I want to talk about the course that you recently did on data engineering. Some folks might not be familiar with that, what that means or what it entails. So can you expand a little bit on what it means in more of a practical way?
Absolutely. So in short, my definition of data engineers operationalize data. Meaning they take data from some particular source system and they transform it in a meaningful way to
We
a
can automate
business or an
just this.
enterprise, and they deploy it into some other, or they load it is the actual terminology, into some other system. And I use this terminology for a few reasons, specifically the operationalized data, largely because the way that data is made use of in the traditional or modern enterprise, I should say, drastically differs from business to business. There isn't a blueprint for how to analyze sales data. There isn't a blueprint for what pharmaceutical analysis should look like. So, data engineers are bringing the infrastructure to the analysts, the scientists, and oftentimes even themselves as folks who are responsible for operationalizing data in meaningful ways. Businesses themselves are becoming more and more data driven. And what we're seeing with the advancements in AI is largely accelerating a business or an enterprise's desire to become data driven. So that course is really an introduction to how to operationalize data in an enterprise through orchestration, specifically through a technology called Airflow. There's a long-standing principle, this ETL, extract, transform, load principle, that actually started in accounting way back in the 70s, that started getting applied to data engineering challenges, to other kinds of technology challenges. So that course is how to think of and how to develop a framework for solving data problems using a technology, Apache Airflow, to actually extract data, transform it, and load it, and do this all in an orchestrated way. And I think this is one of the really interesting things that we're seeing in this space, where open source technologies have come so far, and they've actually come to the point that they're competing and easy enough to deploy with existing large scale vendors. So, democratizing the knowledge about how to both do the ETL process from a business perspective and an engineering perspective, and how to deploy a technology, Apache Airflow, to doing this in an orchestrated way was the purpose of that course.
It's always interesting to me that all these technologies come from the companies that need it the most. And then they're nice enough to open it up for all of us to be able to take advantage of. But of course, it makes sense that somebody like, Meta would develop technology like React that would just make their life a lot easier. And we've seen sort of all these technology companies kind of come up with the technologies that eventually kind of go to everyone. So I had never heard of Airflow, and found it pretty interesting. And I think the best technologies are the ones that come as a result of solving a specific problem that then get opened up as more other companies are kind of interested in that. So talk a little bit about how one gets to be a data engineer and what is the traditional path. Because I feel like when we go to school, there is no specific job. Like data engineer wasn't a thing that you could take in college. So can you talk a little bit about what are also some of the opportunities for somebody studying in that field?
Yeah, I think you're asking a very interesting question because I don't think there's a traditional path to becoming a data engineer. Um, I think what's really interesting is uh, you see data engineers as folks who come from the data ecosystem in some phrase. They're data practitioners or in some world. They can be analysts, data scientists. They can be software engineers. They can be just business intelligence users, or more often than not, they can just be folks who are interested in understanding and querying data inside of their own enterprise. So the path to becoming a data engineer, I think, is fairly uh, unique depending on the individual. Oftentimes, I almost feel like data engineers, I actually called another blog post I wrote the inadvertent data practitioner, where you are an individual who is excited about using data in some meaningful way, but you have to jump through all of these hoops and that you've never been formally trained on and have become thus an inadvertent data practitioner, setting up your own SQL, setting up your own DBT, your own Airflow, and actually building a version of what we call the modern data stack on your own. That being said, I think what's interesting about this session is I have a theory that data engineers are actually going to become the individuals in the enterprise who are responsible for helping enterprises operationalize data for use in these machine learning models, specifically these generative AI models. If you look at a lot of the workload of a traditional data engineer, I mentioned this ETL. You extract data from some source database, you transform that data, and then you load it into additional like database, data set, table, kind of wherever you want. If we look at this, that tended to be structured data. And so, underneath the umbrella of structured data engineers, they would read from databases and other places of structured data. They would transform and they would load into databases or other places of structured data. What's really interesting is I think we're going to see the rise of the unstructured data engineer, where instead of just tabular data that exists in SQL or Oracle, you're going to see folks who are now extracting data from PDFs or PowerPoint presentations or Word docs, transforming that data into some meaningful way, and loading that data into potentially vector databases or even models themselves, fine tuning these models with the business's internal information or contexts. How can I take that information and put it into a meaningful, almost like a cache like context, and stick that in front of a model and query everything through that memory that I'm artificially giving it? So I think the opportunity for data engineers has just 100x in the last few months or even years with the rise of these generative AI models. And the folks who are most likely and most knowledgeable about operationalizing data in a business have already been the data engineers. So companies that are excited or interested in developing an AI strategy or deploying an AI model are likely going to turn to the data engineers to do exactly that.
Hmm. So, do you feel though, like if you were in school today and you have heard about all of these kind of opportunities with AI, that there is, I don't know, a prototype of the type of person that would really enjoy this sort of field, and perhaps like, do you see any patterns in people who are data engineers that repeat? It's people that, I don't know, love data, they love SQL. We have Terrence asking us like, how can somebody get into this field? So sort of advice for individuals that are very interested in what should I do, because all I can take in school is maybe computer science or something very generic.
I think this is going to sound very self-serving, but it's the exact reason that I think I was excited about working with LinkedIn Learning. The reason that every one of the folks on this show are on the show. My goal was to democratize knowledge in every way possible. And so publishing a course on LinkedIn Learning, like the intro to data engineering, specifically the hands-on intro to data engineering course, was to help folks like Terrence who are excited about getting into this field. I think what's interesting is in in the old, I guess when I graduated college, software engineers were coders, right? They
Hmm.
understood how to write code. They understood generally how to do some level of dependency management, and
Hmm.
potentially, hopefully, how to deploy software in a meaningful way. As the software industry has grown, we've seen an abundance of specialization. What the software engineers who are writing code, I mean, they're developers. The folks handling dependencies or even the like infrastructure became either SREs or dev tools or people who are actually building tooling for software engineers. The deployment of software, the handling of outages in the field became DevOps. So people that
Hmm.
were really interested in the operations around what developing and rather deploying these products look like. In the data space, I think we're seeing something similar. People that were previously interested in analyzing data were, SQL analysts. They wrote SQL code, they did aggregations, and that was the primary entry point. You saw this NoSQL movement where more and more people started becoming interested in like not just the SQL, but how the data set or database itself is storing the information. Especially when the data sets got larger, technologies like Cassandra or Presto started
Hmm.
rising, and then there became management for those systems. Then you had folks who were really interested in the business intelligence side who would deploy these insights, and then they became these dashboard creators, or specifically folks who were interested in uh, understanding and creating these models that were then deployed for more intelligence gathering. And then they became data scientists or even ML folks. So I think we're seeing a specialization. And what I see a data engineers doing in this specialization is they're actually the cradle to grave of an organization using data. So if there are folks who are particularly interested in understanding not only like how to work with data in meaningful ways at a variety of scale, how to transform this data, persist it, and how to actually present this information in a meaningful way to their own leadership, I think it's a very compelling and very strong career path. I also think we're going to see additional expertise required in actually managing these systems at scale. Most organizations had some basic sales data that's sat in Salesforce or sat in a Monday.com like system, and the scale actually wasn't huge. There wasn't as much information to analyze. The pipelines didn't need to be as big. Now, when any bit of data in an enterprise is eligible to be put into these models or put into these memories, we're going to need folks that understand how to do that in very powerful and very meaningful ways. So I would say, kind of in short, if you're interested in data engineering, you are somebody who loves operationalizing data, you're data driven by nature, and you really want to use technology to make an impact at your business.
That's really interesting. We had Walter Shields a few weeks ago talk about the concept of dark data, that there is so much data that's already been captured, but perhaps not analyzed, that I think that we're going to see kind of an opening up of somebody that is like a data sleuth, not just somebody that can, look for that data, but somebody that can take that data and operationalize and understand that right now the AIs, at least, they don't know what questions to ask. So they don't know what sort of questions that they can extract from existing data. We have location data, we have purchase data, we have geospatial data, and all of this other generative stuff that can do things with the same data that we have had, perhaps that was never, because of the way that we can now take a look at millions of parameters, all that stuff has never been looked at in a new way. And I think that people that really enjoy that aspect of operationalizing data are going to really do well. And it's so that maybe that love of data in computer science and how all of these different systems can actually make that works for somebody. So I do think that the artificial intelligence field is really giving you new tools, but in the same way, computers can now train themselves on patterns that they learn from analyzing existing data. So, how do you think that is going to change the role of a data engineer if the computers are doing at least part of what was thought of as, the job before?
Yeah, it's a great question. I think what's interesting with if you look at these models, they're really great at generating code to some degree. They're great at actually looking for patterns or looking for ways of at least creating a knowledge graph almost of information that's given. What these models can't do really well, or actually at all, is cite sources or fix things if a pipeline fails. I think this is kind of one of the most interesting things where if you look at a model itself, it is usually a bin file that just lives in some system. Companies like Snowflake and Databricks now have a way of storing these models inside of their systems as well. But that's virtually it. You can almost think of it as a data set or a table that just lives in a database. All of the work required to give it the context or give it the information that it needs, from the code being generated to even the cleansing. Like, the existence of these models doesn't automatically make code clean or make data clean, unfortunately, is actually a pretty fundamental part of what I think the future of data engineering will look like. I also think in the space of the data engineer's toolkit, the end to end, where you just abstract and pull as much data as you can, transform it, and load it into as many systems as you can, is going to become a more intelligent process. Right now, we have folks where ETL can be, I have a table in Snowflake, I'm pulling information in and then dropping it in Snowflake as well. Uh, Now, what if I have data in Snowflake that I get some insights in, and I want to actually have that information into a different system, maybe a streaming system, maybe any kind of like linear processing system as well. I think it's going to look the data engineers themselves are going to change the operating model from what was previously I just do a basic ETL operation to I now have to make intelligent decisions about how I extract the data, how I transform it, and how I load it into end systems. And so the models themselves have done a great job of, once they have the data, giving us information that hopefully is correct, but any of the piping or infrastructure necessary to give the models that information will still be in the realm of data engineering pretty squarely.
Yeah, I think you probably agree with me that people that really understand the technology understand that it's not going to take away like the roles that we see today. It's just going to change them quite a bit. In the same way that now, since anyone can do a podcast, what does that mean? That means that you just have to do a better job or create a more interesting podcast because everybody can do one. So I think that we're going to see sort of a level of quality change. What I always say is when we figured out how to do shipping more efficiently, we didn't get less shipping. We have like way more shipping now. And, the other day I read an article where Amazon doubled down on like fast shipping, like same day, immediate kind of shipping. And we have never had more deliverers in the history of mankind. We thought, oh, eventually, that will all go in. What we've gotten is more of that. So I think that the volume of what people can do, and I love what you said about the democratization of things is just going to change, what everybody is going to be doing. So talk a little bit about what you think are some of the opportunities where maybe smaller players, smaller companies can now compete with much bigger companies because of all this technology.
Absolutely. I think I will say, probably on behalf of most startup folks in the ecosystem right now, I would not recommend competing against a foundational model, meaning getting as much info, unless you have some very massive, magical new insight. Trying to compete against, Claude or GPT-3, 4, or any of these iterations, it's incredibly time intensive and an incredibly complicated endeavor from both a cost perspective as well as a compute perspective. So I would say, as a startup, the best thing that you can have is somebody who's spending money on your behalf. And so for me, I think of, as you were saying earlier, Ray, what are the interesting applications? But what am I uniquely suited, or what kinds of problems am I uniquely suited to target, given that not only do these models exist, many of them are actually free. Like companies like Anthropic, Databricks put out a model called Dolly, which I've been playing with like a ton. These are just available to download, and you can host them on your laptop. Most laptops are actually powerful enough to host a lot of these today, and you can do some pretty meaningful stuff. So I think what's really powerful about any technological advancement, including open source technology, the development of something like a Cassandra or an Elasticsearch didn't necessarily take away people's jobs or software engineers' jobs. What it instead did is had them focus what their unique specialization was in a very powerful way. So I wouldn't have to worry about things like, an index being created incorrectly with like corruption in it, when I knew that there was a library and a corpus of people who are actually making sure something like an Elasticsearch is working properly and correctly. So I think opportunities for small companies are really around the opportunities for what problems are meaningful to the founders or the early employees. And those problems can be anything in terms of, is there a particular issue that you're encountering in your life? Two, if you're an infrastructure person, what do the pieces of infrastructure look like in this ecosystem? Like your Llama index or LangChains is one implementation, but other ways of actually improving on that. You have your Pinecone, your Chroma, or any of the vector databases. Are there ways of improving on that? If you're in the research field, your Word to Vec or your GLOVE algorithm, global vector algorithm, are there ways of improving on that? I actually think what this has done is the large players have actually given many of the smaller folks this incredibly powerful tool that is in these large language models that allows smaller, maybe even less technical founders to write code, deploy product. It allows people to brainstorm, create marketing, at least ideation. And so I think that's really how I think about it. They have the ultimate democratization is giving somebody access to tooling that is truly differentiated. And we've seen that with a lot of what OpenAI has done, a lot of what Microsoft themselves have done, Anthropic as well, Databricks. So I think we've seen some really powerful things.
So one of the interesting things that you said was that it's difficult to compete with this kind of sort of not established, but these companies that have done a lot of work in these fields. However, if you think about it, somebody like OpenAI is basically a much smaller company than a Microsoft or than a Google, and they were able to do something that Google couldn't do. Because I feel like Google perhaps never considered releasing something that wasn't trustworthy. Like, nobody thought of that. And so they figured, well, it does like 80% of the work. It's actually pretty good. It helps people a lot and it's valuable enough to launch. And you also mentioned Anthropic, which I think came from people from OpenAI. So I think that there's a lot of kind of I don't know, creativity happening in all kinds of aspects of the field. I was talking to you about the company called Descript, who's like revolutionizing the way that something like video production is done. So we're seeing a combination of sort of like new techniques combined with people who are kind of taking these models and kind of messing around with them, experimenting with them to kind of get new things out of the models. So what are your thoughts on some of these opportunities and perhaps tools from different companies that are going to either develop or that companies can actually use to differentiate what they're doing?
Absolutely. I think what I would really say is a company needs to define. I mean, I'm going to sound like a broken record, but I think a company needs to define what its data strategy is before, and what kind of company it wants to be before they start deploying some of these tools. I think you're right. Where there's a rush, and I'm sure a lot of CXOs feel pressure seeing their competitors deploying AI or the marketing material that's gone out about how ubiquitous this stuff is going to be. But the reason I really say that is one important component of this whole conversation is non-determinism. The models are incredibly powerful, as we've spoken about. But the reality is, for as long as the model is not deterministic, it is not going to be easy to deploy that model in a mission critical situation. As a very basic example, I actually chatted with the CTO of Boeing many months ago at this point, where they're trying to figure out their AI strategy and they've defined some stuff as well. But the challenge remains, even from the CTO, what does the non-determinism actually mean for their ability to use these in situations like flying a plane. I think the difficulty is the innovation in those areas. They'll need to happen with heavy R&D firms at universities, or even at firms like Microsoft, Google, all of those places. And that's why I really think the opportunities for the smaller folks tends to be in the application, where don't get me wrong, if you are someone who's so passionate about building and deploying one of these models, you should completely do that. But that's where I'm saying, the opportunities are you as an employee of a large scale entity with the right governance and approval from your organization can actually make meaningful use of these models just in your day-to-day uses. Even if it's something like as basic as a document summarization, or something as let me create some kind of collateral and see if that's something that works right out of the box. I think that's where the meaningful opportunities really are, largely because the more the technological advancement occurs and the more open source work that we see, the field will continue to change. And people that made bets, like friends of mine that have made bets on companies that started in March of this year, are not working at those companies anymore or have drastically pivoted because of some of the changes that people have seen. And so finding a problem that's actually meaningful to you as an individual or as a founder or as an early employee, I think is actually the most meaningful thing that you can do. I also don't want to dissuade people from competing with Microsoft, OpenAI, or any of these you know vendors. I believe what they have that really differentiates them is data. If you're Salesforce, as an example, you happen to generally have access to Salesforce information. You can run models on top of emails in Salesforce. If you're Slack, which is also owned by Salesforce, you can also do some meaningful, even sentiment analysis or other kind of generative AI work in Slack conversations. So it always goes back to what is the unique and differentiated data that you have access to. And this insight isn't super unique. It's kind of one of the fundamental predicating portions of hedge funds, right? Hedge funds are able to look at data, buy data, and analyze data in very unique ways and draw unique insights. The same thing I think will need to happen for folks engaging with these models. And that's where the creativity really comes in.
Yeah, and I think that what I always think of is in the gold rush, the people that made a lot of money weren't the people looking for the gold. They were the people building the infrastructure around everything that was happening with the gold rush. And I think that there are, as you mentioned, I think there's so many opportunities out there that haven't been explored yet, that nobody has seen this, you know, this level of capabilities from tools that are just entering the market. And that's where a lot of opportunities happen. So, what do you see as the future of this combination of the data engineering and these developments in AI? So, what's your key takeaway? What should this audience know?
Absolutely. So the first thing is there was a leaked Google memo from a while ago, which pretty much stated that no one has a moat in this space. They don't have a moat. OpenAI doesn't have a moat. And a moat in this context really means something that is so uniquely differentiated that they will just, like they're able to defend their IP in powerful ways. I think what we're seeing right now is nobody has that moat. And as such, the infrastructure around the foundational models also doesn't have a moat. So you see, yeah, this is a memo. You see things like LangChain, Llama Index. I'm going to pick on this Chroma, which are these open source, incredibly powerful tools that just treat these models as almost a black box. They don't go in, they don't introspect them. They just give you the infrastructure and templates for you to interact with these models as though they're just an API. I think what this group should know is this is an incredibly quickly moving space. Standards haven't been defined yet, and we're not going to see standards defined both from a legislative side, I think, for a while, but also from just an operational side or a best practice side, I think, also for a while. Best practice meaning what technology do I deploy with my AI stack? I do think as I mentioned before, this unstructured data engineer and the rise of people that are doing analytics will on unstructured data is a huge area for opportunity and it's a huge area for innovation. There are companies like Unstructured.io that actually are able to extract meaningful data in really powerful ways from sources we wouldn't normally expect, like PDFs, PowerPoint. Um, think they can even pull in like HTML and do some pretty magical things. I think what's really interesting in this space is you mentioned the gold rush example. What does it look like to bring in infrastructure that enables every player in this space to do what they do best? Meaning, let me let the models that generate information do what they do best. Let me let the uh, like extraction tools do what they do best, and let me focus on the meaningful application. And so, with all of that, I go back to the future of actually working with these models will be in the hands of data engineers. There's It's very unlikely a model or an enterprise will want to use a model that doesn't have some form of its own rules, whether those rules are governance, whether those rules are just in terms of like information that should or shouldn't be produced, whether it's even sensitive or proprietary code names that exist in those models. The idea of supplementing a model's knowledge with information in your company, in a company, is actually going to be one of the biggest use cases. So people that can help that process happen, I think, is just they're in a very powerful position to not only uh, make a lot of money, but solve pretty fundamental problems in an enterprise. And so the last thing I'd say for this audience is definitely spend some time and energy and take advantage of the fact that so much of the open source ecosystem exists and is available to you right now. Like at this moment, I can go download Llama Index. I can use Hugging Face's API. I can use Chroma for a vector database all in memory. I can use Dolly. There's so many things and opportunities that exist right now that just building in the space and picking a problem that's meaningful to you is a really powerful place to be.
Such a great concept that we're in the space that everybody it's like a new internet rush. When the first internet rush kind of happened, everybody was trying to come up with things to do. And you're seeing that now, but like times 10. I've never seen anything move so fast and things change so quickly. And, you know, sort of capabilities being given to everyone almost definitely weekly. It's every week there's about 10 new exciting developments that are happening. I can't even imagine what the future is going to be like in 10 years. I think we would be so wrong. It's almost like when you watch those like really old movies from like the 50s where they thought that by the 60s we would have like flying cars and stuff like that. I feel like it's just going to be wildly different and it's going to come at us pretty fast. So thank you very much for coming to the episode. I do want to mention a few places where you can watch more of the show if you're interested, and just to ask everybody to, of course, like and subscribe everywhere. We're in different platforms, so look us up on YouTube, on LinkedIn, of course. We do have a page where you can learn more about the show. The best sort of way to find out about the show is through the weekly newsletter. So after each show, I put together a newsletter with show notes of what happened. I look up all the links of what we mentioned and put them all in there so you can access them and get sort of the key takeaways from each show. There's also, of course, a place where you can look at all the upcoming and previous episodes from the show, and a YouTube playlist as well as an audio podcast. So next time we're going to be talking to Samira Dolan. She's a solutions engineer at Salesforce, and we're talking about the role of the cloud in artificial intelligence, something that perhaps not a lot of people are talking about. What happens to all these things that we have been sort of taken for granted? Like, what's the role of those things in this new world? So thank you again, Vinu, so much for coming. I know you have another course in the pipeline, so everybody please follow Vinu. You can see his LinkedIn link right there, and definitely go check out that data engineering course. Fantastic course. Thank you again, Vinu.
Thank you so much, Ray. I appreciate it.
Talk to you later.